Alright, in this video I want to take a look at a problem that can be done two ways, and I bring this up only because just to illustrate that often there's more than one way to actually find the derivative of a function depending on how you view it. Using algebra you can change how things look, and to suggest that sometimes it's easier to do one rather than the other, and for those who take high stakes tests, that can often be useful. So I'm going to make two columns here and do this problem in two ways. The first way is just to note that we've got a quotient here, so why not use the quotient rule? So if you haven't learned the quotient rule, I recommend looking at a previous video on the quotient rule. But using the quotient rule, I'd probably call my numerator f and my denominator g, and recall that y prime is g squared in the denominator, g f prime minus f g prime. And so if I call f 3x squared plus 7x, that means that f prime is 6x plus 7, and that means that g prime is just 4. And so this is going to become g in the bottom squared, so 4x quantity squared, and g in the top would be a 4x times f prime 6x plus 7 minus f, which is 3x squared plus 7x, times g prime, which is a 4. And again, we can stop here if we'd like. So I will stop here for now. And now let's go do this problem a different way. So how could we do this a different way? Well, the only way to do it a different way is to actually view this problem as, and by the way, there aren't only two ways to do this. But another thing to notice is that this expression can be rewritten using algebra. And so let's just say, rewritten way. Using the rewritten way, we could really just break up this fraction as 3x squared over 4x plus 7x over 4x. And that becomes 3/4 x plus 7/4. And so when you view it like that, the derivative is really easy because the derivative is just going to be 3/4. So what does that mean? That actually means that this expression over here on the left must reduce to 3/4, but you can see that by rewriting how this function looked, it got us to the derivative much more quickly. But just to convince you that we got the same thing, I'm going to distribute that. That gives me 24x squared plus 28x. And this all becomes minus 12x squared minus 28x divided by, let's just multiply that out, 16x squared. And so it looks like my 28x cancels, and I've got left on the top 24x squared minus 12x squared, which is 12x squared, divided by 16x squared. The x squared canceling gives me 12 over 16, which sure enough is 3/4. So you can see the advantage of rewriting it, and just use this video as an example or as a lesson in which you can you remind yourself to consider how you could potentially rewrite a function to make taking its derivative easier.